Hello student, welcome to my channel Learn Physics. Today I will be discussing the chapter vectors, that is definition of vector, types of vector, vector addition, that is triangle law, polygon law, parallelogram law, resolution of vector, and representation of a vector in terms of unit vector along the coordinate axis. This video will be extremely beneficial for you to get the clear concept in physics. Please like, share, comment on it, and to get the best result, subscribe my channel. Okay, now let's start. First of all, definition. The physical quantities which have both magnitude and directions are called vector quantities. These quantities are added with the help of triangle law of vector addition, such as the displacement, velocity, such as displacement, velocity, momentum, force, torque, angular momentum, electric field, magnetic field, etc. are the vector quantities. Electric current both have magnitude and direction, but it is not a vector because it does not obey the triangle law of vector addition. Okay. Now types of vector. Look at this collinear vector. Vectors are on same line or parallel line are called collinear vector. Look at this. Suppose this is the A vector, this is the B vector, and this is the C vector. They are on the same line or in the parallel line, so they are collinear vector. The angle between two collinear vector is equal to 0 degree. Okay, now coplanar vector. Look at this, the vectors are on the same plane is called coplanar vector. Look at this, the screen is a plane, so look at this, all the vector drawn on this plane are the collinear vector. Okay, look at this, this is the collinear vector. Okay, understood? Next. Now look at this co-initial vector. Vector having same initial point are called co-initial vector. Look at this, all have same initial point O, so they are co-initial vector. Now coterminous vector. Now coterminous vector. Vector having same terminal point. Look at this, same terminal point are called coterminous vector. Understood? Now equal vector. Two vectors are said to be equal if they are equal in magnitude and opposite in direction. That is, suppose two forces here both have magnitude 10 Newton. Two forces, look at this here, two forces both have magnitude 10 Newton and directed in the same direction, they are equal vector. Okay, the angle between two equal vector is always 0 degree. Understood? Now opposite vector. Vectors having same magnitude but produced in opposite direction. Look at this. These are the opposite direction are called opposite vector to each other. The angle between two opposite vector is, look at this, the angle between two opposite vector, this is the 180 degree. Okay. Now unit vector. The vector of unit magnitude is called unit vector. It is represented by the cap symbol. Okay. Or if a vector is divided by its magnitude, then the resulting vector is called unit vector. Suppose look at this here, a cap equal to, this is the a vector divided by modulus of a vector or magnitude of a vector, magnitude of a vector. Okay. Suppose velocity of a body be 2 meter per second due east. If this is divided by the 2 meter per second, then we get only 1 due east. So 1 due east is the unit vector directed in the direction of east. Okay. The unit vector along x axis be xi cap, along y axis be yj cap, and along z axis be zk cap. Okay, so look at this. This is the I cap, this is the j cap, and this is the k cap. This is the x axis, this is the y axis, and this is the z axis. Okay, now pseudo vector. The vector directed along the axis of rotation are called pseudo vector. The torque, okay, the torque, angular momentum, angular velocity are the pseudo vector. For anticlockwise rotation, the pseudo vector directed upwardly, and for clockwise rotation, it is directed downwardly. Okay, no problem. Now, triangle law of vector addition. Okay, look at this. If two adjacent sides of a triangle represents two like vector, both in magnitude and direction, then third side taken in reverse order represents their sum. Look at this. This is the A vector is directed along the side AB vector, and this is the B vector directed along the side BC. So resultant of A vector and B vector represented by the side AC directed from A to C. So look at this. This is the resultant vector R vector equals to A vector plus B vector. Okay. Now parallelogram of vector addition. Look at this. This is the look at this. This is the two adjacent sides of parallelogram. These two adjacent sides represents two like vector both in magnitude and direction. Then the diagonal passing through the common point of these two vectors represents their sum. So look at this. Here, look at this. This is the A vector. This is the B vector. So diagonal passing through the point of intersection of the two sides represents their addition. Okay. So look at this. The diagonal R vector, this equal to this is the A vector plus B vector. Okay. Understood? Now we have to calculate magnitude and direction of R vector in terms of magnitude of A vector, magnitude of B vector, and angle between the two vector. Look at this. This is the angle between the two vector. And we also calculate the R vector makes angle of R vector makes with the A vector. Angle of R vector makes with the A vector. This angle theta. Look at this. A perpendicular CD is drawn on produced AB. So look at this. This point is the D point. Look at this from triangle. Look at this from right angle triangle BCD. Look at this CD by B. This equal to sine theta. No problem. So look at this CD equal to this is the B sine theta. Again BD by B, this equal to cos theta. So look at this BD equal to this is the B cos theta. Okay. So look at this from right angle triangle OCD. OC is the hypotenuse, CD is the perpendicular, and AD is the base. So look at this here AC square. This equals to this is the AD square plus CD square. No problem. Now look at this. This is the R square. Okay. Now look at this AD. AD equal to this is the A plus B cos theta. So look at this. This is the A plus B cos theta whole square plus CD. CD is the B sin theta whole square. Okay. Look at this. This is the A square plus 2AB cos theta. This equal to this is the B square cos square theta plus B square sin square theta. No problem. So look at this. This is the A square plus 2AB cos theta plus B square. This is the cos square theta plus sin square theta. Okay. This finally get R equals to this is the root under of this is the a square plus b square plus 2ab cos theta. Because look at this, cos square theta plus sin square theta is equal to 1. Now we have to calculate phi. So look at this here, tan phi, this equal to CD by AD. Now CD is the B sin theta and AD is the A plus B cos theta. Okay, understood? Now some special cases. When theta equal to when theta equal to 0 degree. So cos 0 degree equal to 1. This is the maximum value. So resultant R becomes maximum. So look at this here, R max. This equals to root under of this is the a square plus b square plus 2ab into 1. So look at this here, R max. This equals to a plus b. That is when two vectors directed in the same direction, their resultant is the algebraic sum of the two vectors. Okay. Now, now when theta equal to, look at this, when theta equal to 180 degree. So cos 180 degree equal to this is the minus 1. So look at this here, this 1 is replaced by minus 1. Therefore, look at this R mean this equal to root under of this is the a square plus b square plus 2ab, this is the minus 1. So look at this, this is the a minus b. So minimum value of resultant is the subtraction of two vector or difference of two vector. Okay. So look at this, resultant are always greater than equal to a minus b and always less than equal to a plus b. Okay. Now when theta equal to 90 degree, that is vectors are perpendicular to each other. If theta equal to 90 degree, then this term becomes 0. So here r is equal to root under of this is the a square plus b square. Okay. Now now look at this. Now again, if magnitude of a vector and b vector equal, that is a equal to b. So look at this, tan phi, this equal to this is the b sin theta divided by this is the a plus b cos theta. Now look at this is the b sin theta, this is the 2 sin theta by 2 cos theta by 2. And look at this is the b plus this is the b cos theta. Okay. So look at this here, tan phi, this equal to this is the b sin, this is the theta by 2 cos theta by 2, and this is the b into this is the 2 cos square theta by 2. Now this and this cancel out, and this is the 2 and 2 cancel out, and look at this cos theta by 2 and this 1 cos theta by 2 cancel out. So here cos theta by 2. Now you get this is the sin theta by 2 and this is the cos theta by 2. So look at this, tan phi equal to this is the tan theta by 2. So phi equal to theta by 2. That is the resultant of two equal vector bisect the angle between them. Okay. Now some numerical relating to triangle law. Now look at this example 2.1 of HC verb. Two vectors having equal magnitude A make an angle theta with each other. Find the magnitude and direction of the resultant. So look at this here, A equal to A, the B equal to this also A, and angle between them is theta. So look at this, R equal to this is the A square plus B square plus 2AB cos theta. Now this is the under root. So you get this is the a square plus 2a into cos theta. This equal to this is the 2a square, this is the common, this is the 1 plus cos theta. Now look at this is the 2a square into 2 cos square theta by 2. So look at this. This is the 2. So look at this. This is the 2a cos theta by 2 is the resultant. And phi, look at this, as two vectors are equal, so the phi is equal to the angle bisector of angle between them, that is phi equal to theta by 2. Okay, understood? Now look at this, a vector plus b vector equal to c vector, and a vector and a plus b equal to c. We have to calculate the angle between a vector and b vector. In the same way, if the resultant becomes a minus b equal to c, then also you have to calculate the theta. And if the resultant is the a square plus b square root under, we also have to calculate theta. Okay, in the same way, a vector minus b vector equal to c vector and a minus b equal to c, we have to calculate the angle between theta. So look at this here, all these numbers are the same types. Now we solve only one problem and you can easily solve the other problem. Now look at this, we have to solve this problem. Okay, look at this here, a vector plus b vector equal to c vector. So from triangular vector addition we get c equal to, this is the root under of, this is the a square plus b square plus 2ab cos theta. Okay, now here c equal to a plus b. So look at this, this is the a plus b whole square is equal to root under of, this is the a square plus b square plus 2ab cos theta. Now squaring this, now look at this, squaring this. So here a plus b whole square, this equal to, this is the a square plus b square plus 2ab cos theta. So look at this here, a square plus b square plus 2ab equal to here a square plus b square plus 2ab cos theta. Now look at this here. Now look at this here, a square cancel out, b square cancel out, and this cancel out. So look at this, 1 equal to, this is the cos theta, so theta equal to 0 degree. In the same way, if this condition holds, theta becomes, this is the 180 degree. Now in this case, theta is equal to 90 degree. Now look at this, in this case, theta equal to, this is the 180 degree. Now in this case, this is the theta equal to 0 degree, and in this case, this is the theta equal to 90 degree. Understood? Now look at this case. Now look at this numerical. Okay, look at this here, a vector plus b vector modulus of, this is the a vector minus b vector modulus. So look at this, this is the a square plus b square plus 2ab cos theta, this equal to, this is the a square plus b square minus 2ab cos theta. Okay, no problem. Now look at this cancel out, this cancel out. So look at this, 4ab cos theta, this equal to 0. So cos theta equal to 0. Therefore theta equal to 90 degree. Okay, understood? Next. Look at this, the resultant of two vectors of magnitude 3p and 2p is r. If the first vector be double, then resultant becomes 2 times. Find the angle between the two vectors. Now look at this. Now look at this. This is the 3p. This is the 2p. And resultant is r. If first vector be double, look at this. First vector, suppose this is the 6p. This is the 2p. Second vector same. Resultant is twice r. So this is the 2r. Now in first case, look at this. From first case, look at this. This is the r square equal to 3p square plus this is the 2p whole square plus this is the 2 into 3p into 2p into cos theta. Now look at this. This is the 3p square plus 2p square. So look at this, 9p square plus 4p square. So this is the 13p square. plus look at this. This is the 12 p square cos theta. This is the r square. Okay, equation number 1. From second case, look at this. This is the 12 whole square. This equal to, this is the 6p whole square plus 2p whole square plus this is the 2 into 6p into 2p into cos theta. Okay. Now look at this. This is the 36p square plus 4p square. So this is the 40p square. So look at this. This is the, look at this. This is the 40p square plus look at this. This is the 6 into 2 12, 12 into 2 24. This is the, look at this, 24 p square cos theta. So this is the 4r square. 4r square equal to 40 p square plus 24 p square cos theta. So look at this. If we divide this equation by 4, we get, this is the r square equals to, look at this. This is the 40 p square plus 24 p square cos theta divided by 4. So look at this. This is the 10p square plus 6p square cos theta. Now look at this. This is the r square and this also r square. So look at this. This equal to this. Okay, no problem. Therefore, look at this. This is the 13p square plus this is the 12p square cos theta. This equal to, this is the 10p square plus this is the 6p square cos theta. So look at this. This is the 12p square plus 6p square. So look at this, 12 minus 6. This is the 6p square cos theta. This equal to, this is the 10p square minus 13p square. So look at this. This is the cos theta equal to minus half. Cos theta minus half means cos 120 degree. So theta equal to 120 degree. Okay, understood? Next, look at this. Look at this. This is a polygon. Okay, this side represents vector A. This side represents vector B. This side represents vector C. This side represents vector D. This side represents vector E. So resultant of this vector represented by the remaining side of the polygon taken in reverse order. So this is the R vector. Okay. Look at this. This is the O. This is the A. This is the B. This is the C. This is the D. This is the E. So the statement of the polygon law is, if the sides of an open polygon represent some like vectors both in magnitude and direction in a given order, then the closing side taken in reverse order represents their sum both in magnitude and direction. Look at this. This is the A vector, B vector, C, D, E vector are in the same order and result in R vector in reverse order. Now there is a drawing. Look at this. OB, OB joint. Okay. This is the OC joint now. This is the OD joint now. Okay. Look at this from triangle. Look at this from triangle OAB. Look at this. Here OB vector, this equal to OA vector plus AB vector. So look at this. This is the A vector plus B vector. No problem. From triangle OBC. From triangle OBC. Look at this here. OC vector is equal to, this is the OB vector plus this is the BC vector. Now OB vector is equal to A vector plus B vector. So look at this. This is the A vector plus B vector plus C vector. Now from triangle OCD. From triangle OCD, this is the OD vector equal to this is the OC vector plus CD vector. Now OC vector equal to this is the A vector plus B vector plus C vector, and CD vector is equal to D vector. Okay. Now look at this from triangle. Look at this from triangle ODE. From triangle ODE. Look at this. Here resultant OE vector is equal to this is the OD vector plus D vector. Now look at this, OE vector is the R vector, and OD vector, look at this, OD vector is the A vector plus B vector plus C vector plus D vector plus E vector. Okay, understood? Uh, Look at this, suppose this is the A vector, this is the B vector. Okay, and now B is projected in opposite direction. Look at this. This is the, look at this. This is the negative B vector. So from here, now look at this. This is the minus B vector. Look at this. This is the A vector. This is the B vector. And this is the minus B vector. So look at this. This represents the, this is the A vector plus B vector. And this represents the angle between, now this represents the A vector minus this is the B vector. This, if this angle is theta, so look at this angle becomes, this is the 180 degree minus theta. This angle is the phi 1 and this angle is also phi. So look at this, from A vector plus B vector, this equal to R vector. So look at this here, R equals to, this is the root under of A square plus B square plus 2AB cos theta. And tan phi, look at this, tan phi 1 equal to, this is the B sin theta divided by A plus this is the B cos theta. No problem. Now look at this here, S vector, this equals to A vector minus B vector. So S equal to, this is the root under of, this is the A square plus B square plus 2AB, and this is the cos of 180 degree minus theta. So look at this is the A square plus B square minus 2AB cos theta. Okay. Now tan phi, look at this, tan phi 2 equal to, this is the B sin 180 degree minus theta, that is sin theta. A plus B cos 180 minus theta, that is A minus B cos theta. Okay. So look at this, R equal to S if theta equal to 90 degree, R greater than S when theta, when cos theta is positive. So cos theta positive if theta less than 90 degree, and R less than S if theta greater than 90 degree. Okay, understood? Now what is the angle between R and S when A equal to B? When A equal to B, the phi 1 is the angle bisector of theta. That is phi 1 is equal to, this is the theta by 2. And phi 2 equal to angle bisector of 180 degree minus theta. So this is the by 2. So here phi 1 plus phi 2, this equal to obviously 90 degree. So A vector plus B vector and A vector minus B vector are perpendicular to each other if A equal to B. Okay. Now a numerical. The resultant of P and Q is root 3Q and makes an angle 30 degree with P. Prove that P equal to Q or P equal to. Now look at this. This is the P vector. This is the Q vector. Okay. And this is the resultant R vector which makes an angle 30 degree with the P vector. Okay. Understood? So look at this. This is the P, this is the Q, and this is the R. Resultant are max in angle 30 degree with P vector, and R is equal to root 3Q. Okay. Here, look at this. Here R vector, this equal to P vector plus Q vector. Now here angle between R and P are given. So you can write R vector minus P vector equal to Q vector. So Q vector is the vector subtraction of R vector and P vector. Therefore Q equal to this is the R square plus P square minus 2RP. This is the cos 30 degree. No problem. So look at this here, Q square equal to this is the R square plus P square minus this is the 2 into R, this is the root 3Q into P into this is the root 3 by 2. Okay. So look at this is the Q square equal to 3Q square plus P square minus 3PQ. Therefore, this is the P square minus 3PQ plus 2Q square equal to 0. Now, this equal to P minus Q into this is the P minus 2Q. This equal to 0. So, P equal to Q or P equal to 2Q. Okay, understood? Next, look at this. The magnitude of sum of two vectors is 32 Newton. Suppose A and B are the two vectors, so A plus B, this is the 32. Okay, and the resultant is 8 Newton. R equals to 8 Newton. And the resultant makes an angle 90 degree with the smaller vector. Suppose B is the smaller vector. This is the A vector. This is the B vector. And look at this. This is the resultant vector. Okay. Look at this here. Angle between this is 90 degree. Here, this is the A, this is the B, and this is the resultant R. So look at this here, R vector equal to A vector plus B vector. Here, angle between R and B are given. So you can write R vector minus B vector equal to A vector. So from this condition, A equal to this is the root under of R square plus B square minus 2RB cos 90 degree. So look at this. This is the A square equal to R square plus B square minus 0. So look at this. A square minus B square equal to R square, that is 8 square. Okay. Now this is the A plus B into A minus B. A minus B, this equal to 64. Okay, no problem. Again, this is the A plus B equal to 32. So this is the 32 into A minus B equal to 64. So look at this. Here A minus B equal to 64 by 32. This equal to 2. And A plus B, this equals to 32. So from this relation, you can get A equal to 17 and B equal to 15. Okay, understood? Next. Now, a resolution of a vector. Suppose this is the x-axis. Suppose this is the x-axis and this is the y-axis. Okay. Suppose this is the r vector. Now we have to resolve this r vector in terms of, now this we have to resolve r vector along x-axis and y-axis. Suppose this angle alpha. Okay. If a perpendicular is drawn from r on x-axis, look at this. This is the perpendicular and this also perpendicular. Suppose, look at this, suppose this angle beta. Okay. So look at this, from this triangle, this is the r cos alpha. And look at this is the r cos beta. Okay. Therefore, the component of r vector along x-axis, this is the r cos alpha. If I cap be the unit vector along x-axis and j cap be the unit vector along y-axis, then r vector equal to r cos alpha I cap plus this is the r cos beta, this is the j cap. No problem. If suppose r vector lies in a three-dimensional coordinate axis and this vector makes an angle gamma with the z axis, then r vector can be represented as r vector equal to r cos alpha I cap plus r cos beta j cap plus r cos gamma, this is the k cap. Okay. So if component of a vector along x axis, this is the r cos alpha, this is the r cos beta, this is the r cos gamma. Suppose coordinate of r, suppose initial point of vector be or suppose initial point of r vector at the origin and coordinate of its tip be x comma y comma z, then we can write r vector this equal to x I cap plus y j cap plus z k cap. Now what is the magnitude of the vector? Magnitude is the diagonal of the square. So look at this, this is the x square plus y square plus z square. Now unit vector along r vector, this is the r cap, so this is the r vector by modulus of r. So look at this is the x by r I cap, this is the y by r j cap, this is the z by r, this is the k cap. Now look at this x by r, this is the cos alpha, so this is the cos alpha I cap, this is the cos beta, look at this is the cos beta j cap, this is the cos gamma k cap. Okay. So look at this, cos alpha equal to x by r, cos beta equal to y by r and cos gamma equal to z by r are called direction cosines of the vector. And alpha, beta, gamma are the angle made by the vector with the coordinate axis. If initial point of a vector be x1, y1, z1 and final point be x2, y2, z, okay, then the vector becomes, look at this is the r vector. So look at this, r vector means final point minus initial point. So r vector becomes x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. Okay. Now some numerical related to this. Now look at this, a question. Write the unit vector in the direction of a vector 5 I cap plus j cap minus 2 k cap. So look at this, we have to calculate the unit vector along the vector, this is the 5 I cap plus j cap minus 2 k cap. So you know a cap, this equals to a vector by this is the modulus of a vector. Okay. This is the 5 I cap plus j cap minus 2 k cap. This divide by, look at this is the 25 plus 1 plus 4. So look at this is the 30. Therefore 5 by this is the root 30 I cap. This is the j by root 30 k and this is the j by root 30 and minus 2 by root 30, this is the k cap. Okay. So this is the unit vector along the direction of a vector. Look at this, objective 1 of H.C. Verma. Which of the following set may represent the magnitude of three vectors adding to 0? Look at this, 2, 4, 8 cannot form a triangle. So they never get the 0 magnitude. 486 does not form a triangle. The resultant of this vector is not 0. Now 1, 2, 1, yes. Look at this. This is the 1, this is the 1, and this is the 2. So resultant of these three vector becomes 0. But this is not 0 because they not form a triangle. Okay. Now look at this. The resultant of A vector and B vector makes an angle of alpha with A vector and beta with B vector. Then which are correct? Suppose this is the x-axis, this is the y-axis, this is the resultant vector r vectors. Okay. Suppose this is the A, this is the B, this is the alpha, this is the beta. Okay. So from figure, if r be the resultant, then look at this. A equal to this is the r cos alpha, and B equal to this is the r cos beta. So look at this. If alpha greater than beta, then A less than B. Because greater the value of alpha, smaller the value of cos alpha. So smaller the value of A. So look at this. This is not correct. This is not correct. This is correct. Okay. Now question number 4. The component of a vector is A always less than its magnitude, always greater than its magnitude, always equal to its magnitude. The component of vector may equal, less or greater than a given vector. So ABC not correct, therefore D is correct. Let C vector equal to A vector plus B vector, and modulus of C vector is always greater than modulus of A vector. No, not correct. Resultant of two vectors may greater, less or equal to a given vector. Okay. So look at this. This always statement makes it false. It is possible to have C less than A and C less than B. Yes, it is correct. C always equal to no. C never be equal to A plus B. No. Resultant, look at this. Resultant may equal to sum of the two vector and difference of the two vector. Okay. So only B option is correct. Let the angle between two non-zero vector A vector and B vector be 120 degree. Then the resultant C becomes. C must be equal to A minus B. No. It greater than A minus B. C must be less than. No. C must be greater than A minus B. Yes, it is correct. Therefore, C option is correct. Now, C must be equal to A minus B. No. It is the minimum value. So, C minimum, this equal to, this is the A minus B modulus. Must be less than. No. Never be less than. Now, C must be greater than A minus B. Yes, it is correct because it is the minimum value of resultant. So, resultant must be greater than this. Okay. Now, question number 4. The x component of the resultant of several vectors is equal to the sum of the x component of the vectors. Okay, no problem. May be smaller than the sum of the magnitude of the vectors. No. May be greater than the sum. No, not correct. May be equal to sum of the magnitude of the vectors. Now, look at this a numerical. Look at this. Now, look at this. This is a numerical. This is the numerical from H.C. Verma. Let A equal to 4I cap plus 3J cap. B equal to 3I cap plus 4J cap. Find the magnitude of A vector, B vector, A vector plus B vector and A vector minus B vector. Now magnitude of A vector, this equal to, this is the 4I cap plus 3j cap. So magnitude of A vector is A equal to root under of, this is the 4 square plus 3 square. So this is the 5. Now magnitude of B vector, look at this magnitude of B vector, this equal to, this is the 3I cap plus 4j cap. So this is also equal to, this is the 3 square plus 4 square. So this is the also 5 unit. Now magnitude of A vector plus B vector, look at this A vector plus B vector equal to 3I cap plus 4j cap. So look at this, the magnitude of A vector plus B vector, this equal to, this is the root under 7 square plus 7 square. So this is the 7 root 2, that is the 10 Newton. Okay, so that is the 10, okay, unit. Now A vector, now A vector minus B vector. So look at this, this is the A vector, this is the B vector. So A vector minus B vector is the I cap minus j cap. So modulus of it, this is the A vector minus B vector. This is the modulus of 1 square, this is the minus 1 square. So this is the root. Okay. Now look at this question number 3. Add the vectors A vector, B vector, C vector, each having magnitude of 10 units, each having magnitude of 100 units and inclined to the x-axis at an angle 45 degree, 135 degree and 315 degree respectively. Okay, no problem. Now look at the figure. Okay, look at this. This is the x-axis. This is the y-axis. Okay, no problem. Look at this. One vector makes an angle of, look at this, one vector makes an angle of 45 degree. Another vector makes an angle 135 degree. Look at this. And third vector makes an angle of, look at this, third vector makes an angle of, this is the 315 degree. Okay. So look at this. So look at this. This is the 100. This is the 100. This is the 100. So this and this are cancel out. Only this is the resultant. So resultant is the first. So this is the 100 units along. Now this is the resultant is the 100 units and at an angle 45 degree with the x-axis. Okay, understood? Next. Now question number 6. The vectors have magnitude 3 unit and 4 units respectively. What should be the angle between them so that magnitude of the resultant two vectors have magnitude 3 units and 4 units respectively? What should be the angle between them if the magnitude of the resultant 1 unit, 5 unit and 7 unit? Now you know r square equal to, this is the p square, this is the a square plus b square plus 2ab cos theta. Here a equal to 3, b equal to 4 and resultant r is equal to 1. So look at this is the 1 square equal to 3 square plus 4 square plus this is the 2 into 3 into 4 into cos theta. So look at this is the 1 minus 9 minus 16 equal to, this is the 24 cos theta. So cos theta equal to, this is the minus 24 by 24. So this is the minus 1 equal to cos 180 degree. Therefore theta equals to 180 degree. Okay. Now in the same way you can calculate the angle theta when resultant is 5 and angle theta when resultant is 7 units. This answer becomes 90 degree and this answer, this is the 0 degree. Okay. Many thanks for watching this video. This video will be extremely helpful for your preparation in NEET, main and advanced. To get the best result, subscribe my channel. Okay, thank you.